Hey everybody, Mr. Bennett here. We're going to start a new series. Today we're going to start looking at forces. And forces, put simply, it's a push or a pull. And this can be on you, it can be on an object. So my pen right now, I can push and pull it around. It's a push or a pull. And there's a lot to it, but we're going to be talking about it in these simple terms. In forces, we can say that they're balanced. And if two forces are balanced with one another, there is no movement. This could be multiple forces, even 4, 5, 6, 7, doesn't matter. They can either be balanced, which causes no movement, or they're unbalanced, which becomes the root of motion. So in the last series, if you remember motion, we can measure the distance something travels, how fast it goes from one place to another. We can use acceleration to describe velocity changes. All of that is easy to describe, but to describe what starts that motion, we need to be talking about forces. And we describe these, or we describe balanced versus unbalanced with something called net force. So we are going to be looking at the total force on an object or on a thing. And when we draw diagrams, we use vectors. Remember, vectors shows quantity or magnitude as well as direction. So when we're drawing these vector arrows, what we can see is how hard or how strong that force is in a given direction. So we're going to look at 3 examples here. So we're going to have a balanced force here. And the balanced force would say you've got an object or a thing. If I push, we're going to use blue for forward. So if I'm pushing this direction forward, equally that direction. So I've got 2 forces and they are acting equally on this object. Whatever that object happens to be, we have a net force of 0. And this means there is no movement. This object is not going to move one way or the other. We can also look at a different object, so let's just use a square this time. This is going to be an unbalanced force. And we can take this one of 2 different ways. So the first thing we could say is if I have two small forces acting this direction and one force acting the other direction, this is an unbalanced force, and so our net force, our net movement or our net change for this object is going to be to the right. It's a vector, so the object will start to move to the right because the forces are unbalanced. The same thing goes if you have it the other direction. So I can have 2 leftward facing arrows, or up or down, it doesn't matter. If the forces are unbalanced, your net force is going to change. So this one, the net force goes to the left. So we're going to be adding and subtracting these forces from another. Here, if you had quantities on these, they would cancel each other out, give you a net force of 0. Here you would have 1 to the right, and again in the third one you'd have 1 to the left. So net force can describe the total amount of force, and if it is unbalanced, that's when you get motion. So if there is an unbalanced force, if there's unbalanced force, this should be an object is accelerated by that force. And we know acceleration is a change in velocity over time. So if I'm starting, my velocity is 0. As I start to accelerate my object, right, my velocity begins to change. So we're going to be looking at acceleration again. So in addition to measuring acceleration, we can use force and quantity by using a unit called newtons, N-E-W-T-O-N-S, named after Sir Isaac Newton, who really started physics, and he actually also partially invented calculus, so that's beyond the scope of this class. But Isaac Newton was a smart guy, so he gets his own unit, and this Newton force, or it quantifies the force of an object, and we show this with the capital letter N. So you're going to be seeing that unit around a bunch, starting with the next section. So as always, a couple critical thinking questions down here at the bottom. Take a look at those, and if you have questions, leave me a comment below, and if I have you in class, I'll see you in class.